All right, let's plunge into today's deep dive.
Right.
We're tackling a topic that might sound like it belongs only in the realm of coding experts, but trust me, the insights here about smarter problem solving apply far beyond just writing software.
Mm-hmm.
We're talking functional programming in Java. Now, if Java or programming feels a bit intimidating, don't worry. This deep dive is tailor-made for you, the curious learner, because at its heart, it's about handling information in a more predictable, more powerful way.
Yeah, definitely.
We've pulled insights from a fantastic beginner's guide to functional programming in Java. Okay, let's unpack this.
That's right. At its core, functional programming is, well, it's a style of building programs that treats functions as the primary building blocks.
Oh,
Imagine each function as a tiny, dedicated machine. You feed it some data and it gives you a result, all without ever changing the original data you put in.
I love that image of a tiny, dedicated machine. And our source material gives an even more vivid analogy, doesn't it? Think of functional programming as a recipe.
Ah, the recipe one, yeah.
Each step function takes ingredients, data, produces a result, and leaves the kitchen, original data, unchanged. That unchanged part feels really significant.
It absolutely is. That immutability, the data remaining unchanged, is key because it leads directly to predictability.
Predictability, right?
Unlike traditional programming, where data might be constantly modified as a program runs, functional programming treats these functions almost like mathematical equations.
Okay.
Feed them the same input, and they will always produce the exact same output. This consistency eliminates a huge class of errors.
So Java, which has always been known as, well, predominantly object-oriented language,
Mhm.
wasn't always built for this, was it? It sounds like a pretty big evolution.
You're spot on. Yeah, Java made a significant shift. It added robust functional programming features, starting with version 8, way back in 2014.
2014, okay.
It was about more than just keeping up. It fundamentally expanded how developers could approach problem solving, making the language even more flexible and, well, powerful for modern challenges.
Yep. And when we talk about functional programming in Java, we're talking about specific tools, right? Things like Lambda expressions,
Lambdas.
which are essentially tiny, unnamed functions that do one simple thing, like adding two numbers. Or streams, which are like a conveyor belt for your data.
Exactly, like a conveyor.
And functional interfaces, which are blueprints for how these little functions should behave. So for someone just trying to grasp the concept, how do these tools fit into the bigger picture?
Excellent question. These tools are precisely what allows Java to embrace this functional style. Think of them as the specialized wrenches and screwdrivers in your functional programming toolbox.
Okay.
They streamline the process, enabling you to write those focused, predictable functions we discussed in an incredibly concise and reusable way, ultimately making your code much cleaner and easier to maintain.
That makes a lot of sense. But here's the critical point. If traditional object-oriented programming, or OOP, has served Java so well for decades, why shake things up? What specific headaches does functional programming truly alleviate that traditional methods just complicate?
You've hit on the core of it. While OOP is fantastic for modeling complex, real-world objects and their behaviors, right? For certain types of operations, especially those involving transforming and managing collections of data, it can lead to surprisingly convoluted code.
Right, lots of loops and temporary variables.
Exactly. Functional programming offers a distinctly cleaner, often more elegant solution for these challenges.
How so?
For example, it drastically simplifies data processing. Imagine you have a massive list of customer orders and you want to filter out all the pending ones, then sort them by date.
Okay, common task.
In traditional code, you might write long, nested loops that are easy to get wrong. Functional programming lets you express these operations with simple, clear functions that describe what you want to achieve, not how to do it step by step.
Declarative versus imperative.
Precisely. This also leads to far fewer bugs.
Yeah.
By emphasizing immutable data, meaning you never change the original data, you essentially eliminate an entire class of mistakes, like accidental overwriting. It makes your programs far more predictable and reliable.
Fewer bugs sounds like a programmer's dream come true.
It truly is one of the most compelling advantages, yeah. Reducing those frustrating hours spent chasing elusive errors. And it's surprisingly well suited for modern computing needs. Think about preparing a huge meal for 100 people.
Okay,
If everyone in the kitchen is using and changing the same pot of sauce, you'll have chaos and mistakes, right?
nevertheless, yeah.
But if each chef is given their own bowl of ingredients to transform and they just hand back their finished component without touching anything else, the process is far smoother, faster, and less error prone.
I see the connection.
That's essentially why functional programming makes handling big data and running many tasks at once on multi-core computers so much easier and safer. It avoids those chaotic shared pot situations.
Right, concurrency becomes easier.
Much easier. Plus, it encourages cleaner, more concise code by promoting short, reusable functions, cutting down on the clutter often seen in traditional approaches. And yes, it was also crucial for Java to add these features to stay competitive with modern languages like Python or Scala that inherently use functional programming.
So for someone new to this, it sounds like functional programming is a powerful new tool in your toolbox. It's not always needed, but for specific jobs like handling data or making code more reliable, it's incredibly effective.
Exactly. It genuinely expands your problem-solving toolkit. It's not about replacing OOP entirely, but complementing it.
Understanding the why makes functional programming incredibly compelling. But the real magic, and where developers often have that aha moment, is seeing how these ideas actually come to life in Java. So let's pull back the curtain. What are the foundational principles that make this new tool hum?
At its heart, functional programming operates by ensuring that functions are treated as first-class citizens. These functions take inputs, produce outputs, and critically, they avoid side effects.
Side effects.
Yeah,
Things happening outside the function itself.
precisely. This brings us to a few core concepts. First, pure functions. A function is pure if it always gives the exact same output for the same input.
No, like math.
Exactly like math. And it doesn't change anything else in the program. For example, a function that just doubles a number is pure because 5 will always become 10. And critically, it has no side effects.
Right.
Imagine a function that also saves something to a database every time you call it, or prints a message to your screen, or, updates a global counter outside its own scope. Those are side effects, and functional programming minimizes them because they make your program much harder to predict and debug.
That's a huge departure from directly changing variables or performing actions that affect other parts of your program.
It's a surprisingly significant leap, actually, but one with huge payoffs in predictability and testability. Second, immutable data.
We touched on this.
Yeah, this means instead of changing original data, functional programming creates new data with the results. If you have a list of numbers and you want to filter it, you don't alter the original list. You create a brand new list with only the filtered numbers.
So the original list is untouched, safe.
Always safe. Third, functions as values. In Java, you can actually treat functions like data.
Like passing a number around.
Exactly. You can pass them to other functions, store them, or return them. This allows for incredibly flexible code, like handing a specific sorting function to a list to dictate precisely how it should be ordered.
Very powerful.
And fourth, chaining operations. Java's functional tools are designed to let you string functions together, processing data step by step. You can take a list, then filter it, then sort it, then transform it all in one smooth flow, almost like an assembly line.
Like building a pipeline.
That's a great way to put it. And this chaining often comes to life through streams. Java uses streams to handle collections functionally. Picture a stream like that conveyor belt again. Why? Where your data flows through a series of functions like a filter or a sorter to get the final result, all without ever changing the original data that started on the belt.
And those shortcuts we mentioned earlier, Lambda expressions, those short unnamed functions and functional interfaces, which are like the blueprints for functions.
Yeah.
They're really what make this chaining and treating functions as values possible and elegant in Java, right?
Absolutely. They are the concise syntax, the glue that brings these powerful concepts to life within Java without tons of boilerplate code.
So let's connect all these dots. What specific everyday programming problems does functional programming directly solve that programmers often, well, pull their hair out over? And what are its broader advantages for anyone building software?
Well, it directly tackles the pain of complex loops. You know, those long, error-prone blocks of code traditionally used to process data?
Oh, yeah. Hard to read, easy to mess up.
Totally. Functional programming replaces them with simpler, chainable functions that are much easier to read and verify. It also virtually eliminates data corruption issues. Immutability prevents those insidious bugs.
The ones that only show up sometimes.
Exactly. Those bugs that come from accidentally changing data, especially in large or multitask programs. And for parallel processing, where running tasks simultaneously can be a nightmare due to shared data.
Yeah, race conditions and deadlocks. Ugh.
Right. Pure functions and immutable data make it profoundly safer and easier to manage. No shared mutable state, no problem, basically.
Makes sense.
It dramatically helps with code clutter, too. While object-oriented code can sometimes become quite verbose for simple data transformations, functional programming simplifies things with short, highly reusable functions. It cuts down on unnecessary lines of code.
Less code, fewer places for bugs to hide.
That's the idea. And finally, maintenance challenges. Traditional code can be tough to update or debug in big projects. Functional programming's predictable functions and clear modular structure make code far easier to maintain, debug, and test efficiently.
Those really are major headaches for anyone working with code, so the benefits must be truly significant then.
They are indeed. The direct advantages include significantly fewer errors because predictable code means dramatically less time spent fixing elusive mistakes.
More building, less fixing.
Exactly. It leads to easier to read code, as functional code is often shorter, more focused, and flows logically through chained operations. You also get inherently reusable code because functions act like versatile, independent building blocks.
Like Lego bricks.
Kinda, yeah. For data tasks, you often see better performance because Java's streams and parallel processing really excel at speeding up handling large data sets. Testing is also far simpler.
Because of pure functions.
Exactly. Pure functions are isolated and easy to verify, same input, same output every time. And finally, scalability is improved, making it much easier to scale programs for bigger data or more tasks, which is vital for modern applications like web servers or complex data analysis systems.
That's a compelling case.
Yeah.
So for you, the learner who might be just starting out or looking to deepen your understanding, what does this all mean for practical application? How do you actually start using this?
Right, good question. For beginners, it's about starting smart and gaining confidence. Don't try to rewrite everything functionally overnight.
Baby steps.
Definitely. Try using functional programming for simple data tasks first, like filtering or sorting lists.
Okay.
For example, next time you have a list of invoices and you want to filter out all the paid ones or sort them by date, try to resist the urge to write a traditional for loop.
Pause and think functionally.
Yes, think. How can I pass this list through a filter function, then maybe a sort function? Java streams make this incredibly intuitive once you get the hang of it, and you'll immediately see the benefits in clarity. Focus on understanding pure functions and immutability. They're truly the heart of functional programming and simplify so much. Experiment with Java's stream features. Think of it like building that pipeline for data we talked about.
Data flowing through operation.
Precisely, where it flows through various operations.
Mm-hmm.
And crucially, remember that you don't need to use functional programming everywhere.
It's not all or nothing.
Not at all. It's a powerful approach that combines beautifully with object-oriented programming for the best results. It acts like a specialized tool in your wider development toolkit. Think of functional programming as a way to make your code cleaner and more reliable, like organizing your tools for easier use, ensuring you pick the right one for the right job.
This deep dive has truly shown that functional programming in Java is, well, it's a really powerful approach. It simplifies complex tasks, cuts down on errors, and makes code much more maintainable.
Yeah.
It truly represents a powerful evolution in how many developers approach their craft.
It really does.
And understanding it can fundamentally shift your own problem-solving mindset. And as you start to explore these ideas, that's where it gets really interesting.
Yeah, as you practice and experiment with these concepts, you'll discover that functional programming is a fantastic way to handle data and build incredibly robust programs. It truly can make your Java journey more exciting and productive.
So here's a thought to leave you with. If functional programming is a powerful tool in your programming toolbox, and not the only tool, how might understanding different approaches, like this one, change how you tackle problems in any complex system, whether it's code or project management, or maybe just dealing with daily information overload? Keep exploring, keep learning.